Finite simple continued fractions have what we can call shorter and longer representations. In this video, we'll explain what we mean by shorter and longer representations, and we'll discuss the process for converting between the two. Let's get started. It is helpful to review and keep in mind that finite simple continued fractions can be written in this generic form: a0, a1, a2, and continuing on until a sub n minus 1, and ending with a sub n. A key point is this ends. There is an a sub n, so this is for a finite simple continued fraction. We'll use 101 over 27 to illustrate what we mean by longer and shorter representations. If you expand 101 over 27 into a simple continued fraction, the result is 3, 1, 2, 1, 6. This is a0, a1, a2, and this is a3, which is also a sub n minus 1, and this is a4, which is also a sub n. There's another way to represent the same number, 101 over 27. Here it is, 3, 1, 2, 1, 5, 1. Both of these simple continued fractions equal 101 over 27. The terms are the same through here, but the last two terms are different. You could probably guess the one to the left is the shorter representation, and the one to the right is the longer representation. Do you believe these two continued fractions represent the same number? Stop the video and see if you can convince yourself that they do. One way to see that they equal each other is to write them out longhand. For the shorter representation, here it is. 3 plus 1 over 1 plus 1 over 2 plus 1 over 1 plus 1 over 6. For the longer representation, I'll just fill it in. Here it is. These parts are the same, but these parts are different. Writing it this way makes it easier to see that the 6 on the left is replaced with 5 plus 1 over 1 on the right. So when we went from the shorter to longer representation, all we did is replace one form of writing 6 with another. In the process, though, we got another term. The shorter representation has 4 terms, so n equals 4, and the longer representation has 5. Having one more term means there's one more convergent. Can you calculate the convergence for one or both of these continued fractions? Give it a try. For the shorter representation, they are 3 over 1, 4 over 1, 11 over 3, 15 over 4, and 101 over 27. As expected, the last convergent equals the number that we expanded. For the longer representation, it has these, which are the same, but then it has 86 over 23, which is different. And it ends with 101 over 27, just like the shorter representation. It has to. So all of these are the same, but the longer representation has this one additional convergent inserted just before its last convergent. A few comments. Finite simple continued fractions have exactly two representations, the shorter and the longer. There aren't any others. Another comment is that when you expand a rational number, the result is the shorter representation. Then you have the ability to convert it to the longer if you like. All of this might seem academic right now, but there is some benefit in having the ability to change the number of terms and the number of convergents. We'll be putting this to use in future videos. We'll see that there are reasons to convert from one representation to the other. Now let's look at that, the process for converting between the shorter and longer representations. First, converting from shorter to longer. We can do this as long as a sub n does not equal 1. Can you write down a process? Stop the video and give it a try. It's pretty straightforward, nothing tricky here. Subtract 1 from a sub n and append a 1 at the end. In the example, that's what we did. We took 1 away from 6 to get 5 and appended a 1 at the end. Appending the 1 causes n to increase by 1. Now let's talk about going the other way, from longer to shorter. We can convert from longer to shorter if a sub n equals 1. All you do is add 1 to a sub n minus 1 and cut off or truncate the original a sub n. When you do this, n decreases by 1. I should emphasize that all this is for finite simple continued fractions. Infinite simple continued fractions don't end, so they don't have a last term, what we're calling a sub n in this video. We talked about what we mean by longer and shorter representations of finite simple continued fractions and jotted down a process for converting back and forth between the two. That's all for now.